Hello students, good morning to all. Today we are going to continue the chapter of algebra, that is applications of matrices and determinant. In this last class we have seen solving of system of linear equations. So that continuation classes will be go on. Now already we know the system of equations can be written m linear equation in n unknowns can be written in some equation. Last class we have written in the form of matrix form. From the matrix form, how to solve now we are going to see. So the above system of linear of equation can be written in matrix form as A11, A12, A13, A11, A21, A22, A23, A2n. So likewise, the continuing the same way, we can get AM1, AM2, AM3, AMn into x1, x2, x3 equal b1, b2, bk. In this, where A is called, so we can written in this first matrix can be considered as A, the next one is x, then last one is b, where A is called coefficient matrix and b is also numbers. We have a numbers, its short form we can write in way of A equal to Aij, where I is varies from 1 to m, j is varies to 1 to n, b is bk, where k is 1 to n. Then here A is called a coefficient matrix. We are combining the matrix of A and B right in a single matrix, that's called augmented matrix. Already you know the meaning of augmented. Augmented means we join what the matrix is given. We are going to take the one more matrix and join it, right? We will get the augmented matrix of AB. That can be represented with the notations of square bracket of A oblique B, then square bracket. So from this, make use of these augmented matrix and coefficient matrix. We are going to solve the solution system of solution equation. Before that, we want to know what is homogeneous equations and non-homogeneous equations. So in homogeneous equations, so we have the matrix of B. In the matrix of B, all the elements of B is 0, means that is called homogeneous matrix. That means instead of B1, B2, Bk, we are having all the elements are 0 and 0. That means B is nothing but 0, 0, 0 comes. So if it comes all the elements of B matrix is 0, then it is called homogeneous equations. If non-homogeneous equation means at least any one of the zeros is not there, that is any one non-zero element is there, mean it is called non-homogeneous equation. Now we are going to see the non-homogeneous equation, how the solve, we are going to solve solution of to the system of equation of non-homogeneous equations. For that, suppose we want to solve, we must know the two terms, one is consistent, another one is inconsistent. Consistent means a system of linear is having at least one solution. So system of equations means we can have all the variables. We have, suppose already in lower class we have studied maximum of two linear equations, that x and y. We can, after solving the solution, we are getting the values of only one value for x and one value for x. That is called consistent. A system is having at least one solution is called consistent. No solution is called inconsistent. So then what is, after in solutions consistent, we have at least one solution we are taking it. Then there is a two possibilities. One is unique solution, one is infinitely many solution. Unique solution means there is exactly one solutions. We can able to find the system of equations. Infinitely many solution mean, so we can find the different solution for the system of equations. After that, next we must know the important note. Number of system of equations is equal to number of unknowns. Then the coefficient matrix A is a square matrix. If A is a square non-singular matrix, the solution of the system can be found by any one of the following method. So there are three methods. In that, one is matrix inversion method, next one is Grammar's method or grammar rule, third one is Gaussian elimination method. So in this, now let us see the first method. We have to go and see detailing in matrix inversion method. For that inversion method, first we have to convert the system of equation. What are the equation given to you in any number of unknowns? First convert into matrix form. That is in the form of Ax equal to B. In that we want to find the value of x. That is the solution formula is A inverse of B. Because this already you know this, because A into A inverse equal to I. You know the formula. So make use of this formula, we are getting this. That is free multiplying A inverse with Ax. So this can be rearranged. A into A inverse into A into x equal to B. This is I. So Ix equal to B, because A inverse into A is I. You know the property. Thus A inverse A equal to I. You know this property. Make use of this property. Means Ix is nothing but x equal to, so here we pre-multiplying it, A inverse of B. So this is A inverse of B. This this is the result we got it. So that's directly we have written it. So this is the way how to come. There is no need of this. Only this result is enough to know means. Now we go for the one example. We'll do it. So instead of example I am taking the sums from the exercise 1.3 first Roman. That is, solve the following system of equations in matrix inversion method. In that I took the first sum, 2x plus 5y equal to minus 2 and x plus 2y equal to minus 3. Then after getting this, go for the solution. In this solution, you write the above system in matrix form. So I have written the coefficient matrix, that is 2, 5, 1, 2 as a one matrix. Then variable x and y. Then variable of right side what value you are having, that is minus 2, minus 3 is in another form of matrix. This is in the form of Ax equal to B. Suppose Ax equal to B means we are able to find the solution, we need this form, that is x equal to A1, A inverse of B. For that purpose, A inverse, we have to find out whether the given coefficient matrix is non-singular or. Already in 11th standard you have studied singular or non-singular. If A is a matrix, if determinant of A equal to 0, then it is called singular matrix. Already if A in determinant of A not equal to 0, it is called non-singular matrix. If we want to find the A inverse, that A should be non-singular matrix, then only the A inverse exists. For that purpose, we are finding the value of the determinant. The determinant of A is nothing but, write the coefficient matrix and put the determinant sign. So you know how to multiply the determinant. So right top to left down, so left to top to right down, we will have to, that is top to bottom, you have to multiply first, then down to up, you have to go in minus sign, that is 2 into 2 are 4, 1 into 5 is minus 5, 4 minus 5 is minus 1, minus 5 not equal to 0, therefore the A inverse exists. If A inverse exists, so we know this formula A inverse means, we know the formula of A inverse is equal to 1 by determinant of A adjoint AA. For this, we want to find the adjoint of A. So already you have studied, so you know how to find in a 2 by 2 matrix, directly you can write the adjoint matrix. Adjoint matrix is nothing but, so what the matrix A you have, interchange the leading diagonal elements and change the sign of the secondary diagonal elements. So here we have the leading diagonal is 2, 2. So we have both the numbers are the same elements, so we can interchange the 2, 2. Here the same number only comes and change the sign of the secondary diagonal elements, that is minus 1, minus 1. Here they are having plus, put in minus 1, minus 5. So after that, we know the A inverse formula, that is 1 by determinant of A adjoint A. In that you substitute 1 by A, determinant of A is minus 1 and adjoint of A is this one. So after this, we are going to find the value of x. So last step we have to find out A inverse. So now we are going to find the solution for this. The solution is x equal to A inverse of B. Because already A inverse you know this, 1 by minus 1, 2 minus 1, minus 1, 2. We are substituting the value of A inverse and x is nothing but xy. Xy matrix is, x matrix is nothing but xy and B is, that is minus 2, minus 3. Already in the matrix form we have. So we simplify minus 1, 1 by minus 1 can be written as minus 1. I am multiplying these two. So you know my matrix multiplication. So 2 into minus 2, minus 4, minus 5 to minus 3, you will get plus 15. So minus 1 minus 2, 2, 2 minus 3 minus 6. So simplifying this you will get 11 minus 4. So already in outside there is a bracket in minus 1 is there. Multiply the minus 1 throughout the matrix, you will get minus 11, 4. Therefore the solution is x equal to minus 11 and y equal to 4. So next we move, this is 2 by 2 matrix for system of linear equation. How to solve, we know this. Now we move on to, if it is 3 variable, so how to solve. That is, system of equation consists of 3 variables, how to solve. We will go this in the exercise. We have to take the fourth sum, that is x plus y plus z minus 2 equals 0, 6x minus 4y plus 5z minus 31 equals 0, 5x 2y plus 2z equal 13. In this, so we don't have last matrix, we have the B matrices clearly we have, but here we have some 0 elements there, but after the variables we have some constants. So first rewrite the terms in terms of system of linear equation, that is B matrix we want to write, that's why right side we have some constant. So we are that is we have changed and write the equation. The equation becomes x plus y plus z equal to 2. That is minus 2 go to that side become plus 2. 6x minus 4y plus 5 is equal to 31. 5x plus 20y plus 2z equal to 13. It's already in the form, but it is not there. So we change over to this constant to the other side. After written this, then the above system convert into what you did in the 2 by 2 matrix. Same thing you can do for this. This above system can be in matrix forms. First write the coefficient matrix, then the variable, then the B matrix. Then we can see in the form of AXB. After getting this, we want to find the value of inverse. So first we have to check whether A coefficient matrix is non-singular or not. For non-singular means we want to find the value of determinant. That is A matrix. So already we know find the determinant value for A. That we have to remove the matrix sign and put in the determinant sign. That is 1 1 6 minus 4 5 5 2 2. So you know how to expand it. So already we are well versed how to expand the determinant. So we solve according expanding along the row R1. So 1 into, so deleting the same corresponding column and rows. We are multiplying this. We are 1 into 4 and minus 4 into 2 minus 8. Minus 2 into 5 is minus 10. So second term is already you know how to put the signs minus 1. So instead of 6 into 2 is 12. 5 into 5 are minus 25. Then move on to 1. We leave this row and corresponding columns. Remaining element we have to multiply and write 6 into 12. So plus 20. So we are simplifying this. Minus 8 minus 10 minus 18. 12 minus 25 minus 13. Already minus 1 is there. Plus 1. 12 plus 20 32. So removing the sign minus 18 plus 32 13 and 32. So simplifying it we will get 27. 27 is not equal to 0. Therefore A inverse exists. If A inverse exists means we can go for the adjoint matrix. In 2 by 2 matrix 2 by 2 matrix means we can write adjoint matrix directly, but it is 3 by 3. Then we can go and find when the cofactor matrix, and after that take the transpose of the co-matrix, we will get the adjoint matrix. Next we find the cofactor matrix. In the cofactor matrix you know how to find the cofactor matrix, because which term you want to find, leave the rows and columns, remaining terms write in the determinant one, that is in minors. So we'll get like this form. So of course first we have 1 1 6 minus 4 5 5 2 2 in coefficient matrix. So we are going to write the cofactor of 1, that is first row first element, that corresponding row and column leave it, mean remaining we have minus 4 and 5 2 and 2, that can be represented in determinant form. Likewise then alternate terms become minus, the plus and minus, already you know how to find the determinant values, cofactor matrix, how the sign changes, already you know this. So make use of that, we continue it, that's why. Since second A2 1 2 means leave the first corresponding row and column, the remaining elements you will have 6 5 2. In the continuing in the same way we have to complete this coefficient matrix. So after that, so simplify the evaluate the determinant, we will get the values of minus 8 minus 10, then 12 25 like that. So after simplification of this we are getting minus 18 13 22, because already minus 8 minus 10 is minus 18, 12 minus 25 is minus 13, minus 13 multiplied with minus we will get plus. So 12 plus 20 32. So 2 minus 2 0, there will be no minus 0, we take it directly zeros. So 2 minus 5 minus 3. So here minus 3 comes in, already you multiply with minus, you will get plus 3. 5 plus 4 9, 5 minus 6 you will get 1. Then so we will get the minus 4 minus 6 is 1. So this is minus. Okay. Then adjoint is nothing but what the cofactor matrix you are having transpose of is adjoint matrix. Already cofactor matrix there, you take the transpose of this, you will get the adjoint of this, that is minus infinity, that row is changed into column, that is minus 8 0 9 13 minus 3 1, that column is converted into row. Then 32 3 minus 10, that converted into row. This is the adjoint of this. So already you know the formula of A inverse, 1 by determinant of A equal to adjoint A. In that you substitute the value of determinant of A and adjoint A, that is then nothing but this is A inverse. Next you know to find the value of solution, there is a formula for you know this. Therefore the solution is x equal to A inverse of B. So we will see next. Now next move on to the next step. The solution is x equal to A inverse of B. Already x matrix you know x, y, z, and A inverse already we have find out, that is 1 by 27. In substitute the same thing here, that is 1 by 27 minus 18 into minus 18 0 9 13 minus 3 1 32 3 minus 10 into that B matrix, already we know in the matrix form 2 minus 31 13. So multiply the matrix multiply, already we were well versed in that, so we can multiply directly. That first row and first column we are getting this, that is minus 18 into 2 is minus 36, 0 into 31 is 31, plus 9 into 31 is 117. So 13 into 2 is 26, minus 3 into 31 is minus 93, 1 into 13 13. Same way move on to the third row. So 32 into 2 is 64, plus 3 into 31 93, so minus 10 into 13 130. If we simplify the columns, we will get the minus 36 plus 117, that is group the terms of negative terms and positive terms, we will get minus 36 plus 117, then 39 minus 93, then 157 minus 130. Simply this will get the 81 minus 54 and 27. So multiplying with the 1 by 27, we get the value of x, y, z, that is 3 minus 2, 1. Therefore, the solution is x equal 3, y equal to minus 2 and z equal to 1. So try to do the remaining sums in the exercise as ever, practice sums, and same way you take the example sums also, try to do the sums and check it. Thank you.